Hello friends, how are you? In the last class we were discussing about allotropes of carbon. We were discussing about allotropes of carbon, and out of which we discussed two allotropes. First one is diamond and second one is graphite. Okay, and after discussing that we also differentiate between the diamond and graphite. We also differentiated between diamond and graphite. Okay, and as I already told, this question, that is difference between the diamond and graphite, that is very important for our exam. Okay, now in today's class I am starting the third allotrope. That is fullerenes. Got it? That is fullerenes. Okay, if we discuss the fullerene, then it is newly discovered allotrope of carbon. It was discovered in 1985. It was discovered in 1985. Okay, so and on the other hand, the diamond and graphite, they were very well known from the ancient time, but this is newly discovered. That is, it is just discovered in 1985. Got it? It is football like structure. It is football like structure. One thing, let me clear you that here we just only showing the carbon particles. We shown only carbon particles. We are not showing here the double bond single bonds. One thing, let me clear, because there are double bond single bond alternatively present here, so that is not showing here. Here only the carbon particles and their arrangements is showing. Okay, so it is a football like structure, as it is clear, that is, it is a football like structure. The first non-stable fullerene was C60. The first non-fullerene was C60, that is C60 fullerene, in which 60 carbon atoms, the number which is written here, that is showing the number of carbon atoms. So here 60 carbon atoms are arranged into 32 polygons, out of which 20 are hexagons and 12 are pentagons. 12 are pentagons and 20 are hexagon. Like this is pentagon, these are hexagons, that is again hexagon, that is pentagon, that is hexagon, that is hexagon, that is pentagon, like this. Okay, so there are 12 pentagons and 20 hexagons. Got it? Fullerenes are the bad conductor of heat and electricity. These are bad conductor of heat and electricity, and the bond distance between the two carbon atoms, that is 1.4 angstrom. It is 1.4 angstrom. Got it? Now the questions comes in our mind, that why that is called fullerene. Why it is called fullerene? One thing, let me clear you, it is also called buckyball. It is also called buckyball. Fullerene and buckyball also. Got it? Fullerene were named in the honor of the famous American architect. There was a American architect, Buckminster Fuller, whose geodesic dome structure. Buckminster Fuller was a famous American architect. His one structure, which was geodesic dome-like structure, is totally similar with the fullerenes. That is C60. That's why, in the behalf of the name of the Buckminster Fuller, in the honor of the Fuller, it is named fullerenes. These are named fullerenes. Got it? Other than C60, there are C70, C80 and other fullerenes are also, but out of these, C60 is the most stable fullerene. It is most stable fullerenes. Got it? Now let me read fastly. It is newly discovered allotrope of carbon. It was discovered in 1985. It is football-like structure. The first non-stable fullerene was C60, in which 60 carbon atoms are arranged into the 32 polygons or faces, out of which 32 polygons out of these 32 polygons, 20 are hexagons and 12 are pentagons. Got it? Fullerenes are bad conductor of heat and electricity. These are bad conductor of heat and electricity. Bond distance between C60, that is 1.4 angstrom, as we discussed. Fullerenes were named in the honor of the famous American architect Buckminster Fuller, whose geodesic dome structure was similar with the C60 fullerene. Other than the C60, C70 or C80 etc. are also known, but out of these C60 is most stable fullerene. Now the uses. Its uses is very important. That uses can be asked in exam. Okay, so first one is use in the purification of natural gases. It is used in the purification of natural gases because it is a football like structure. So some gaseous particles which are small in size can trap in between them, can trap in the center of the fullerene and can separate from the other component of gases. Got it? So it is used in the purification of natural gases. Second, it is used in molecular bearing, that means binding of molecules. Third, it behave like superconductor at high temperature. At high temperature, it behave like a superconductor. Therefore, it is used in various instruments. Because of that, it is used in various instruments. Got it? Now, some important organic compounds. And the first one is chlorofluorocarbon or CFC. Chlorofluorocarbon, shortly it is called CFC or it is called freons. And it is very, very important for our exam. Got it? Clear? Now the question, the definition of that, the polychlorofluoroalkenes are called freons. The polychlorofluoroalkenes are called freons. That means alkanes, these are alkanes in which the hydrogens of the molecule substituted by chlorine and fluorine. That means we can say that polychlorofluoroalkenes are called freons. These are called freons. Got it? Second definition, we can consider that those alkanes or compounds in which carbon atom is linked with chlorine and fluorine. As we know that in the alkanes, the carbon atom is bonded with other carbon atom and hydrogens. The carbon atom is bonded with other carbon atom and hydrogens. Here, some of the hydrogens substituted by chlorine and fluorine. So we can say that the carbon atom is linked with chlorine and fluorine are called CFC or freons. These are called CFC and freons. Got it? Now, the question comes in our mind that how they prepared. Got it? These are prepared by the halogen exchange reactions in which when carbon tetrachloride CCl4 is react with the hydrogen fluoride in the presence of SbCl5 or SbCl2 both, antimony pentachloride, antimony dichloride, out of these two anyone can use in the presence of the SbCl5 or SbCl2, then when the CCl4 carbon tetrachloride is reacted with the hydrogen fluoride, then the chlorine, one or more chlorine substituted by fluorine atoms. One or more chlorine is substituted by fluorine atoms, and as a result it is CCl3F and HCl. Here the one of the chlorine is substituted by fluorine. Got it? This formed compound is known as trichloro. 3 chlorine, so that is trichloro. 1 fluorine, fluoro, that is methane. Or it is also called freon 11. It is also called freon 11. Got it? Now, there is a topic that is nomenclature of freons. How the name of freons are written. That means there is a basics. The name of freons is different from the IUPAC systems that we discussed earlier in this chapter. It is different. The names of the freon is based on the number of carbon, hydrogen and fluorine atoms. It is based on the number of carbon, hydrogen and fluorine atoms. Got it? Here, the freons are named as freons XYZ. Freons XYZ, where X is denoting number of carbon atom minus 1. That is, the value of X will be the number of carbon atom in that molecule minus 1. Y, that is number of hydrogen atoms plus 1. The number of hydrogen atoms plus 1. And Z, that is number of fluorine atoms. It is Z is denoted by the number of fluorine atoms. Okay, to understand that, let me discuss some examples. So first, as we discussed here, that is CCl3F. CCl3F. Now we have to write its name. Now let me find the value of X, Y and Z for that. X, that is number of carbon atom minus 1. Here 1 carbon, 1 minus 1, that is 0. So X, value of X is 0. Got it? Y, that is number of hydrogen plus 1. Is there any hydrogen? No. Then 0 plus 1, that is 1. Z, which is denoting fluorine. Here 1 fluorine, so that is 1. So the name becomes freon. X value 0, Y 1, Z 1. There is no need to write the 0, so that name becomes freon 11. Got it? Similarly, if we discuss this example, that is X carbon minus 1. Since 1 carbon atom, 1 minus 1, that is 0. Y, number of hydrogen plus 1. Is there any hydrogen? No. So 0 plus 1, that is 1. Z, that is fluorine. Here 2 fluorine atoms. So that Z is 2. So its name is freon 12. Its name is freon 12. Got it? Now let us discuss the third example. Here it is C2Cl4 F2. C2Cl4 F2. Got it? Now we find the value of X. X is carbon minus 1. Since there are 2 atoms of carbon, so 2 minus 1, that is 1. So the value of X is 1. Y, that is number of hydrogen atom. Is there any hydrogen? No. So 0 plus 1, that is 1. Z, it is denoting the fluorine atoms. Since there are 2 fluorine atoms, so Z, the value of Z is 2. So the value of X is 1, Y is 1 and Z is 2. So the name becomes freon 112. Its name becomes freon 112. Got it? Similarly, one more, that is C2Cl3F3. Again X, that is number of carbon atom minus 1. 2 minus 1, that is 1. 2 minus 1, that is 1. Got it? Y, that is number of hydrogen atom. Is there any hydrogen? No. 0. So Y is 0 plus 1, that is 1. Z, which is equal to the fluorine atoms. Here 3 fluorine, so that is 3. So name becomes freon 113. Got it? So in this way we can identify the name of any freon. One more question that can be asked, that by giving you molecular formula, by giving you the name of freon, the examiner can ask its molecular formula. Write the molecular formula. For example, the question is write the molecular formula of freon 11. The question is write the molecular formula of freon 11. As you know, here, if one thing, let me clear you that if there is only two values, then the question that comes in our mind, that is which xyz is eliminated. Here the only and only the value of x can be eliminated from the name of freon. Why? Because y is denoting hydrogen plus 1, so it is always plus 1, always greater than 1, 1 or greater than 1. Why? Because that is h plus 1, h plus 1, so that is cannot be 0. Z, that is which is showing the number of fluorine atom, and you know that these are polychlorofluorocarbons, polychlorofluoroalkanes. That means here the fluorine is definitely present, so Z cannot be 0, y cannot 0, z cannot 0. Then only the one thing that is possible, that is x can be 0. And which condition? If there is only one carbon present in the molecule, then x can be 0. Got it? So here freon 1 2, that means here the value of x is 0, the value of y is 1, and the value of z is 2. As you know that x is carbon atom minus 1, so if we consider the carbon, then we can say that x, as you know that what is the x, c minus 1, what is y, h plus 1, and z, that is fluorine. So now this is given and that is asked, so this minus 1 here, now that is plus 1 here, so number of carbon atom is x plus 1. Number of hydrogens, here the y which is denoting h plus 1, so transfer 1 minus here, so h becomes y minus 1. Z, which is equal to the fluorine, so fluorine is equal to the z. Now here x is 0, so 0 plus 1, that is 1, y, that is 1, so hydrogen atom, that is 1 minus 1, that is 0, and number of fluorine, that is 2. Now it is clear that there is one carbon atom and no hydrogen, there is no hydrogen, and here is two fluorine atoms, so first thing, there is one carbon atom. Got it? Hydrogen 0, so there is no indication of hydrogen. Second thing, that is number of fluorine, that is 2. Now remaining valency of carbon will fulfill by chlorine, because that is chlorofluoroalkane. So chlorine, fluorine, chlorine and fluorine. Okay, so the remaining, since there is no hydrogens, that means the remaining valency of carbon will fulfill by chlorines. Here the two valency is satisfied, so two valency is remaining, so there is two chlorine atoms. So we can write the formula, that is CCl2F2. Got it? Clear? Now uses of freons. It is an inert solvent. It is an inert solvent which can use in various reactions. Okay. Second, use in refrigerators, AC and cold storage. It is used in refrigerators, AC and cold storage. That means we simply said that the gas of refrigerators. This is, got it? Second, okay, so use as inert solvent, use in refrigerators, AC and cold storage. Now the second thing, that is, now our second term, that is compressed natural gas. Our second example is compressed natural gas or CNG. Compressed natural gas or CNG. CNG. Got it? And second thing that we will discuss, that is liquid petroleum gas. Liquid petroleum gas. Okay. compressed natural gas and CNG and liquid petroleum gas, that is LPG. Now we will discuss about them. Okay. Firstly, we discuss about the compressed natural gas CNG. Under the rocks of earth crust and above the petroleum, that is black colored, that is we generally called crude oil, the gases are trapped under the earth crust, deeper inside the earth crust. Suppose these are rocks up, and that are also rocks, and that is petroleum. Above this petroleum, the gases are found, which are known as natural gases. That is called natural gases. These are obtained during the extraction of the petroleum. When there is a drilling, then these gases comes out. Got it? So we can say that layers of gases which are found in the deep underground above petroleum are known as natural gases. These are obtained during extraction of the petroleum. These are obtained when during the extraction of petroleum. Got it? Got it or not? Okay. Now, when these natural gases are compressed at high pressure, then it is called compressed natural gas or CNG. Compressed natural gas or CNG. If we consider the composition of CNG, then it mainly consists methane and other lighter hydrocarbons. It is made up by mainly methane, that is 75% of the CNG, approximately 75% of the CNG, that is methane. Okay, and remaining part is other hydrocarbons. Now if we consider the LPG, then the gases which released during the fractional distillation of the petroleum, as we know that from the soil or earth crust we obtain crude oil, black colored crude oil, petroleum product, and to separate its component like the diesel, petrol, wax and other substances, we do fractional distillation. We perform fractional distillation. Okay, in this fractional distillation, the gases which are released during the fractional distillation of petroleum are called petroleum gases. These gases are called petroleum gases. Got it? When these gases are compressed at high pressure, that means petroleum LPG, are compressed at high pressure and converted into liquid, then it is known as liquid petroleum gas LPG, or it is also called liquefied petroleum gas. Here I write liquid petroleum gas because in our book, English medium books, that is liquid petroleum gas, but it is actually liquefied petroleum gas. Got it? It is mainly consists propane and butane. If we consider its composition, then it is mainly consists propane and butane. Got it? Now, there is two questions which is very important. First, why CNG is more safer than LPG? And second is, why CNG is more environmental friendly or better than LPG? There are two different questions. Here, safer than LPG, and here, better than LPG. Okay. Firstly, consider this about the safety feature of CNG. CNG is mainly consist methane, which is lighter hydrocarbons. So it is lighter than LPG. If there is any leakage, then CNG will rapidly spread out in air and decrease the chances of accident. Because it is lighter, so it will lift up fast and will spread into the atmosphere. On the other side, the LPG is heavier, so it remain at the lower surface of the ground and increase the chances of fire accidents. It increases the chances of fire accidents. Got it? Now the second question is, CNG is more environmental friendly or better than LPG? It is also true. CNG mainly consists lighter hydrocarbons like the methane. So it has less carbon content. So during the burning, it will release less carbon dioxide and carbon monoxides. It will release less carbon dioxide and carbon monoxide in combustion or burning. While on the other hand, the LPG and other petroleum products like the diesel and petroleums, LPG, other substances, they are composed by heavier hydrocarbons. They are made up by heavier hydrocarbons. So, when they burn, they release more amount of carbon monoxide and carbon dioxide. Got it? So, they are less environmental friendly, while CNG is more environmental friendly because it releases less carbon dioxide and less carbon monoxide, while LPG and other, they release more carbon dioxide, more carbon monoxides. Got it? Now, one more question which is very important, that is comparison between the CNG and LPG. All of that point we discussed in our class, today's class, is summarized here. Okay, the first difference is name. We can write one more difference here, that is CNG, that is compressed natural gas, LPG is liquid petroleum gas. We can also write this difference also, that means seventh difference. But if you consider it, that's your matter, that's matter of your choice. Otherwise we have already have 6 or 7 differences. The first difference is CNG is obtained during the extraction of the petroleum. As we discussed, it is obtained when it is obtained during the extraction of the petroleum. Okay, while LPG, it is obtained by the fractional distillation of petroleum. It is extracted with petroleum and it is by petroleum. Got it? Second, it mainly consists methane, it mainly consists butane and propane. It is lighter and more safe, it is heavier and less safe. It is more environmental friendly, it is less environmental friendly. CNG, that is a short, sorry for that point, this point here and that point here. CNG used in automobiles and LPG as domestic fuel. Got it? 6 point. CNG has more calorific value while LPG has less calorific value. Now the questions comes in our mind, that is, what is calorific value? The amount of energy released during the total combustion of 1 kilogram of the substance is known as its calorific value. So it releases more energy, so its value is more, while LPG releases less energy, so its value is less. Got it? So it is more calorific value, it has less calorific value. Got it? So that was the difference between CNG and LPG. Okay, now let us start our chapter's last topic, that is polymers. Poly. Firstly discuss about the name, that is poly. Poly means various. Mer, that is meros, that is small units. So if we consider the name, meaning of that name, then we can say that when the various small units when the various small units combine together, when the various small units combine together and make a long structure, then this long structure is called polymer, and the small structures is called monomer, and the process is known as polymerization. Process is called polymerizations. Okay, so if we consider the particular definition, then we can say that small units or small compounds, when joined together, they make heavier or long chain molecules. These long chain molecules are called polymers. These long chain molecules are called polymers, and the small starting units are called monomers. The small units or simple molecule, when joined together, they make the heavy or long chain molecules. These long chain molecules are called polymers, and the small starting units, by combining that, the heavy molecules is formed, that is known as monomers. Or we can also say that the large long chain molecules which formed by the repetition of the small structural units, because the various small structural units, when repeated, joined together, then this long molecule is formed. So repetition of the small structural units is known as polymers. The starting small structure units are called monomers, and the process of the formation of the polymers is known as polymerization. This process is known as polymerization. Got it? The polymers are two types. One is natural polymers and second is artificial or synthetic polymers. One is natural and second is artificial or synthetic. As the name indicating natural, which the polymers which directly obtained from nature. Polymers which directly obtained from nature are called natural polymers. Example: natural rubber, starch, cellulose, etc. Got it? Now, we have one example, one and only example of natural polymers, that is natural rubber. That is natural rubber, and for your kind information, it is very important question, this polymerization reaction and this name. It is obtained from the latex of the rubber tree. It is naturally obtained material which is obtained from the latex of the rubber tree. Natural rubber is a polymer of isoprene. It is polymer of isoprene. This is isoprene. CH2 double bond CH single bond C double bond CH2 single bond CH3. It is called isoprene. It is its monomer unit, monomer of natural rubber. This can ask, write the name of the monomer of natural rubber. Write the name of monomer of natural rubber. Okay, this is isoprene. Okay, now its polymerization, its polymerization of it gives the polyisoprene, which is natural rubber, got it? Now the questions comes in our mind that how it is takes place. So for that, I'm considering two molecule combination of the two molecules, that is, as we consider the isoprene molecule, then that was CH2 double bond CH single bond C double bond CH2 single bond CH3. That is CH2 double bond CH single bond C double bond CH2, and that is CH3. Okay, this one. Now let me consider one more molecule of that. CH2 double bond CH single bond C CH3 double bond CH2. Okay, now here in polymerization process, this bond, the double bonds breaks. These double bonds breaks and shifted. The breaking of this double bond shift one electron here, and this breaking transfer one electron here. So here now there is double bond. Similarly, here same process is here, one electron here, one electron here. As you know, one bond, that is two electrons. So this one electron, another the remaining of one electron, because one single bond, that means two electrons. One electron shifted here. Now this one electron shifted here, and this one electron is shifted here. That means there is a single bond formation. Similarly, this electron will shifted here and this electron will shifted here. So same units combine in proceeding V. Now it is CH2 single bond CH, double bond C, single bond CH3, single bond CH2. Again CH2 single bond CH, double bond C, CH3, single bond CH2. And similarly, here we discuss only two molecules. If we discuss n molecule, then n molecules will combine. Okay. Now if I consider this and this, is they both are same? Okay, they are same. So I can write like this also: CH2 CH, double bond C, CH3 CH2. Here these two are same, so I can write 2. If I am saying that n molecules are here, then there is n. If there is 2, since there are 2, so that is 2. If I am saying there is n molecules, then here will be n. So we can say that here the CH2 double bond CH, single bond C, CH3 double bond CH2, when it goes under polymerization, then these n molecules join together and make this structure CH2 CH. And I think you understand the shifting of bonds. This, it is known as polyisoprene or natural rubber. Got it? Now that is a one important point, which is vulcanization. What is vulcanization? When acetic acid is added in the latex, it converts into the solid. This naturally obtained rubber has less tensile strength and less elasticity. It has less tensile strength and less elasticity. To improve its tensile strength and elasticity, it is heated with the sulfur. It is heated with sulfur. This process is called vulcanization. That means we can say that to improve, if we consider the exact definition, then we can say that to improve the tensile strength and elasticity, natural rubber is heated with sulfur. This process is called vulcanization. Okay. After it, the rubber becomes strong, hard, and more elastic. Got it? The vulcanization increases its tensile strength, make it hard, make it more elastic, make it strong. Got it? About the synthetic polymers, we will discuss in next class. Thank you. Hope you like it.